Networks are everywhere, and as a hacker, I'm extremely busy trying to find those which are weak in their security and privacy. They are out there, and when I find them, I make sure I steal every piece of personal and protected data that I can find.
It can be really easy to choose an AV over IP system based on the cool feature sets it offers. However, what's more important is understanding how well protected the content which is being sent across the network is. Let's use the car industry as an example. Over the decades, the consumer has been instrumental in making sure the safety of car manufacturers meets a minimum requirement. So much so that whenever we buy a new car today, we automatically expect that car to meet a minimum standard of safety without needing to research it first. Consumer demands are key to pushing manufacturers to meet standards. So, by making sure we are all aware of those minimum standards from an AV over IP perspective, we can really push the manufacturers of those systems to meet our basic security and privacy standards before any other features are considered. Before any other features are considered, it's completely non-negotiable that your AV over IP system has the following 3 security measures in place: encryption, authentication, and vulnerability scanning. Without any of these, your AV and control data is wide open to theft. This course will help you to demonstrate the security parameters of your AV over IP installation to IT professionals by explaining these basic security and privacy features to ensure your data doesn't end up going to places or people it shouldn't. Let's begin with the question why. Why do we need to implement basic security measures to networks? Okay, let's rephrase that question. Why do we lock our houses before we go out to work? The answer to this, of course, is the same for both questions.
It stops the thieves stealing your personal things.
Yes, that's exactly what it is. Yes, you're absolutely right. Let's just lock the door here. Security touches everyone, whether we're protecting our personal possessions from the hands of thieves or protecting data streams from going to places they shouldn't. Basic security and privacy mechanisms need to be put into place. Let's use the SDVoE network topology to demonstrate how security should be implemented, frankly, across any AV over IP system. When the source signals are turned into packets of data, those packets are encrypted before being sent across the network. AES stands for Advanced Encryption Standard, and AES 128 is commonly used to encrypt the data. 128 refers to 128-bit encryption, which is virtually impenetrable. To put this into perspective as to how long it would actually take to crack, the time needed to crack AES 128-bit encryption has been calculated to 1 billion years using the fastest supercomputer available. It isn't just the stream which needs protecting. The signal and control data also needs to be secure. Understanding the vulnerability of each endpoint is important to make sure the correct level of security is applied. Consider the implications of a hacker taking control of a device. The API server which communicates to the AV endpoints will live on a computer running an operating system. And for decades now, cryptography standards and algorithms have been perfected to ensure content within the OS is safe. Relying on these proven standards over a half-thought-out amateur security system is extremely important. Securing access across every element of an AV over IP system is vital. From the client software sending and receiving data from the API server, from the API server connecting to the endpoints themselves, before any data is transferred, authentication must take place to confirm the origin and integrity of the data. This is done using authentication codes, which are encrypted with a key which only the partner device can read. Once the partner device sends back the correct code, that partner is considered authenticated. Manufacturers of any AV over IP system must scan and test their API source code regularly against the most up-to-date list of known security vulnerabilities, providing system updates when needed. Additionally, it's important to ask the control application providers how they secure user access rights and firmware access of the devices. These can also be targets of attack if left unprotected. And finally, the network itself must have physical security and network port control implemented, because total security is only as strong as the weakest link. The pro AV industry must ensure unity and cohesion on the position of AV over IP security. Just like the car industry in the early 20th century, as consumers demanded better safety, the manufacturers had to comply. We are the consumers of AV over IP, and it's down to us to demand encryption, authentication, and vulnerability scanning to ensure a safe, protected system before even considering features such as low latency performance. You have the right to ask if these basic security measures are in place. In fact, you have a duty to ask.